Hi again, so in this video we are going to talk about the move assignment operator and how to overload that, also as a member function. Here's a look at the move assignment operator prototype and definition. You'll notice the main difference between the move assignment operator and the copy assignment operator is that the move assignment operator takes in an R value as an argument. So in the formal parameter we have an R value reference. It is not const because we are going to set the member pointer of other, or in other words of the temporary object that we pass in as an argument. Right, we're going to set the member pointer of that object to null pointer. At this point you should be comfortable enough to try and implement this yourself. So go ahead and try and implement this move assignment operator by yourself before you watch the rest of the video. Okay, so I'll move on to a demonstration in Visual Studio now. We'll continue using the same entity class from the previous examples and from the previous videos. In the entity class we have the default constructor right here. Then we have a deep copy constructor as well. Here we have the move constructor as well, as explained in the previous lecture. Then we have the destructor also from the previous lecture. It simply does a check. If member pointer is not null pointer, then delete member pointer and print out dynamic object deallocated. Otherwise, it's going to print out nothing to deallocate. Then we have this copy assignment operator. We'll use this one in the final example in this lecture. It's simply going to print out copy assignment invoked and then do a check for self assignment. It's going to delete whatever member pointer is currently pointing at. Okay, it's going to deallocate that. Then it's going to allocate a new dynamic variable on the heap, and it's simply going to copy the values over. And then of course it's going to return this by dereferencing this. Finally, that brings me to the move assignment operator. You will notice the difference here in the formal parameter compared to the copy assignment operator. This again is an R value reference, and it's not const because we want to do other.member pointer and we want to assign null pointer to that. Alright, in the definition here we print out move assignment invoked. We check for self assignment. If the two objects are not the same, then continue and go and deallocate what member pointer is pointing at. Then we want to reallocate the resources or steal the resources from other, in other words from the temporary object that we pass in. So we simply copy the address over, we assign other.member pointer to the member pointer of the calling object, and then we assign null pointer to other.member pointer. We want to make sure that the member pointer of that temporary object is null, so that when the temporary object gets destroyed, it does not go and deallocate the dynamic variable. And then we simply dereference this and return that. I also have this toString function where we simply print out the value in the dynamic variable that member pointer points at. Right, so in this example, of course, member pointer is a pointer to an integer. Okay, in main I construct entity1, I pass in 5, and then in the second statement here we assign a temporary object to entity1. This right here is going to construct a temporary object. Alright, we use the class name entity followed by parentheses, and we pass in 55 as an argument for the constructor. The temporary object again is going to get assigned to entity1. And so that should use our overloaded move assignment operator. Let's build and run this and see what happens. Move assignment invoked. It won't have anything to deallocate. Following the assignment, that temporary object gets destroyed. Its destructor gets invoked. Its member pointer is set to null pointer. Remember now that we assigned null pointer to its member pointer, so it will have nothing to deallocate. Then when entity1 goes out of scope, so when we are done with the main function, the destructor is called for entity1, and it will deallocate the dynamic variable that its member pointer is pointing at. Remember, we have the toString function, so I do entity1.toString and build and run again, and we should get 55 printed out. Right, so move assignment invoked, nothing to deallocate, and it prints out 55. Just in case you have a difficult time following along with what's going on here, I'll do another quick illustration for you on the move assignment operator. This illustration is also based on the entity class, so we have that member pointer. In the first statement in the main function, we construct entity1 and pass in 5 as an argument. Okay, and this is basically the state that we'll get on the stack and the heap now. We have that stack frame for the main function, and then we also have the entity1 object that has a member pointer that will point to some dynamic variable on the heap. an integer, right, and that dynamic variable stores the value 5. Then we move on to the second statement in main. We assign an R value to entity 1. The R value or temporary object is constructed. Okay, write the class name, you follow that by parentheses, and you specify the argument. That creates a temporary object or an R value, and we are now doing assignment. Entity 1 already exists, so we are not going to use the copy constructor or the move constructor. Alright, we are going to do assignment. We now have two objects, entity 1 and some temporary object. Both of those point to distinct dynamic variables on the heap. For entity 1, that dynamic variable stores 5, and for the member pointer of temp, that points to a dynamic variable which stores the value 3. We have these two objects now, and in that second statement in the main function, we invoke that overloaded assignment operator, in this case a move assignment operator. Notice the formal parameter is an R value reference. Just like with the copy assignment operator, we want to check for self-assignment. If the two objects are not the same, so if we are not assigning to ourselves, then move into the body of that if statement. Also similar to the copy assignment operator, we want to delete member pointer and allocate what the member pointer of the calling object is currently pointing at. Okay, we don't care about that dynamic variable anymore, so we are simply going to get rid of it, so we deallocate it in that statement. In the next two statements, we want to reallocate the resources to the calling object, okay, to the object that we assign to, in this case entity 1. So we assign other.memberPointer to the member pointer again of the calling object. That will copy over the address, not the value. That means that both the member pointer of the temporary object and the member pointer of entity 1 will now point to the same dynamic variable on the heap. Just like with the move constructor, the next statement is very important. We assign null pointer to other.memberPointer. Other in this example is going to refer to that temporary object, so we set its member pointer to null pointer. And now following the second statement in main, that temporary object is going to get destroyed. Its destructor will not allocate any objects on the heap. It is no longer pointing to that dynamic variable. If we did not do that vital step of assigning null pointer to other.memberPointer, then again it will go and allocate that dynamic variable on the heap. The member pointer of entity 1 in that case would be dangling. As we've seen before, if entity 1 now goes out of scope, the object gets destroyed, the destructor gets called, and if that pointer is dangling again, you'll get a crash. So that is why it's a vital step. We need to assign null pointer to other.memberPointer. And if you do that correctly, you'll get this result now, as you can see in the illustration. And should that entity 1 object go out of scope now, it will successfully deallocate the dynamic variable, and we won't have any problems. As an exercise, before we move on, I'd like you to try and overload the pre-increment operator and the post-increment operator, and then in main write a few statements to use both of those, and you want to assign the result of that computation to an existing entity, so let's say entity 1, and then take note of which overloaded assignment operator will get invoked. You also want to make sure that those overloaded assignment operators print out some statement that says, okay, copy assignment operator or move assignment operator invoked, right? So that you can see which one gets invoked. So at this point you should be able to do that by yourself. Okay, so go ahead and try that by yourself, and then when I come back I'll step you through the overloading of those operators, again the pre-increment and post-increment operators. One final demonstration for you. I'll scroll down right before the toString function, and I'll overload the increment operator. I'll overload both of these for the prefix and postfix versions of the increment operator. I'll go back to main. I'll construct another entity here, entity 2, and I'll pass in an argument of 1. And then in this assignment statement here, I'm going to remove the construction of that temporary object. I'll increment entity 2, okay, and I'll assign that to entity 1. Okay, in this case, he's going to use the copy assignment operator, and then he's simply going to print out 2 again. And then I'll use this postfix increment operator on entity 2, and of course, as you can see here, this is going to return this here, the temporary object. So this assignment statement here should invoke the move assignment operator. And you might be surprised by the output here, but remember the temporary object that we create, So right here, okay, we create that temporary object. If we dereference this, that is going to return an L value, not an R value, so the statement will use the copy constructor. Alright, I'll bring this back here. Then it will actually use the move constructor again. Finally, it's going to invoke our move assignment operator. I'll scroll down. Now, of course, it's going to print out 1 and not 2 because it's going to return the state of entity 2 before the increment. Again, we do here. We return temp, okay, as explained in the lecture where we overloaded the increment operator. But that increment does actually change the state of entity 2. So if you do entity1.toString, that's going to give us 1, and this here, entity2.toString, that should give us 2. Build and run that, and that should work fine, as you can see. Finally, for the move constructor and the move assignment operator, I'll go in and make sure to add the noExcept specifier. Right here with the move assignment operator, for example, you can see a green squiggly. If I hover over that, it says this kind of function may not throw, declare it noExcept. I'll just build and run again. And that works fine. This should go away after a bit. Okay, just give IntelliSense a bit of time to catch up, and that green squiggly will go away. I just thought I'd do a bonus demonstration here for you, and I hope you found this interesting and helpful, and I'll see you in the next lecture.